Hey, how's it going, guys? My name is Travis Kaufman. I'm at Travis Kaufman on pretty much every social medium there is. And this is going to be called Dead Simple Async Control Flow with Coroutines. And all of the example code that you're going to see in these slides is on my GitHub. It's at code-talk-examples, and there's instructions in the README on how to run all of that code. So let's jump right in. So just a quick outline of what we're going to cover today. So the first thing we're going to do is kind of like define the problem. Like, why are we using coroutines in the first place? Like, what's the motivation for introducing another async pattern into our ES usage? And I'm kind of going to move quickly through that because a lot of the motivation, I think, was really beautifully shown in the last presentation. And so I'm going to spend more time kind of digging in under the hood and exploring like what the mechanism for making web frameworks like Koa and other libraries that leverage coroutines, like what the magic is there. How does that actually work? So we're going to present the solution, and the solution is coroutines, which probably is not a shock. And really, what I'm going to do there is I'm going to show the code first, and then I'm going to go under the hood there because hopefully that'll get you excited about using it in your code, and also maybe we'll give you some intuition about how what's actually going on under the hood. Then we're going to explore the implementation. So we'll go over a little bit of theory on cooperative multitasking, and then talk about how it's implemented in JavaScript. And then I want to show you some coroutine libraries. So there are a lot of libraries out there that will let you start using coroutines today. And we'll go over some and look at kind of the pros of each. And then if we have time at the end, I want to show you some advanced usage. So some a little bit more complex example code that does things that would be pretty tricky to do if you were just using promises or continuations. All right, cool. So first thing I want to do is I want to talk about the problem. And so the problem here is the same problem that we always have as Node developers, which is diagonal development, or pyramid of doom, or callback hell, or whatever you want to call it. It's basically, instead of your code looking like a line-by-line sequence of logical steps, it looks like a ski slope of callbacks. And this is bad, right? And I was kind of thinking the other day, well, why is it bad, right? And the reason that I think it's bad is not because it has anything to do with implementation, because the implementation works the same. It's definitely not because of performance, right? But so many people have such a problem with this, and I think the reason is that, is this concept of cognitive overhead, right? So when you're working, right, and you open up a file that looks like this, you really have to parse line by line, with your eyes what's going on here. Whereas you open up equivalent Ruby code or Java code, or well, maybe not Java code, but you get the idea. It's pretty much logically laid out in a sequence of steps, and there's not a lot of work you have to do there, right? And so it's a problem that has to do with intuitiveness, right? And it really gets to this core idea that callbacks are unintuitive, right? And I'm sure we've all seen this meme. So, to kind of put that in context, let's run through an example. So you come to your job on Monday or tomorrow at your super cool startup, and your boss comes running up to you, and she's like, listen, I know that we've been working on this thing for a while, but what's really going to make us millions of dollars is if you write this program that takes in a GitHub username at the command prompt and prints out their 10 most recent repos. So you're like, great, I'm going to do it. And you write it in Node, and it looks something like this, which it doesn't really look bad. It looks pretty good. But there are a couple of things in here that could be smelly or problematic. And the first is that, every time that you get past a callback, you need to potentially handle that error, right? And so for each callback, you have an error handle. And even if you've refactored that into its own function, you're still writing it in multiple places. So you have an issue of code duplication, right? The next thing you have is what we've already seen before, which is the pyramid of doom. This is inevitable when you're writing like async JavaScript in Node and you're not using a library. And the worst thing to me is that, let's say that your callbacks get more complex, right? So eventually what you want to do is you want to take this big heavy function and you want to refactor it into a number of routines, right? If you refactor these functions, that means that you have to jump around your source code file to see where those functions are and kind of follow the logical flow of execution by jumping from function to function, which is really unintuitive, and it really puts a lot of load on your brain just parsing the code when you should be using those cycles actually solving the problems, right? So, a solution a lot of the time was to just use a library like async, which I kind of equate to jQuery's, to Node's like version of jQuery, right? It's like the ubiquitous library that we all love and use to handle this problem, and it's a great library. I've used it in tons of projects, and we get some gains from it, right? So we only have to handle this in one place. So if you're not too familiar with async, basically we do ask for username first, right? That gets called back with the name, then fetch repos runs, and then what fetch repos has to do is it needs to call it back with the error object as well as that original name object and the repos object. And if at any point something bad happens, this whole routine will short circuit and it'll go directly to this callback fulfilling the error object. So this is good. It means we only have to handle this error in one place, which means no more code duplication. But there are some issues, right? So the first one is that we need to make an API change to accommodate library usage. Now, this isn't to say that you couldn't, close over name, so you've got a closure for a name object, and then after ask for username runs, your callback assigns it to that closure object, and then continues on with fetch repos. But any way you slice it, you're going to have to modify your code in order to accommodate this, right? And the second thing is that while async is a super popular library, you still need to be familiar with waterfall and the way it works in order to completely understand what's going on here. So, if you've never seen this before, you do have to, probably go on GitHub, do a little digging, or just ask around in your coworkers. So, thankfully, the folks at TC39, the ECMA committee, they kind of realized that this was an issue, namely, I think, Dominic DeNicola, and we have promises now to handle this. So promises are great. They're my favorite feature in ES 2015, and basically, if you're not familiar with promises, you can kind of think of them as placeholder values for async operations that, and when they settle, you can call then to get the settled value, or you could call catch at the very end to handle errors. And that's a grotesque oversimplification of what promises are. So if you're unfamiliar, I definitely encourage you to check them out more. But basically, this is what we can make the code look like in ES 2015. We ask for the username, which returns a promise. We chain it, and we call fetch repos with it. And so again, the nice thing about promises is that they unwrap. So if your resolver function, if your handler to then returns a promise, it will actually be unwrapped to the top level, so you can then continue chaining it, which is what we do here. And notice that we've changed fetch repos a little bit, so now we actually return an object consisting of a name and a repo's key, which has name and the repo's values, which we can then use to print the repos. And then at the end, we can catch throughout the entire promise chain by calling this .catch method and then passing it handle errors. So no pyramids, no triangular structures at all, which is great. And also the error handling is separated from the general logic, which is a pattern I really like because it keeps the logic really clean and kind of concise, so you don't have to kind of pepper it with error handling mechanisms, right? So that's pretty good, but still a couple of issues, right? So we still have this API weirdness where we have to modify what fetch repos is returning, and we still have to use handler functions for working with those values, right? So can we do better, right? Wouldn't it be nice if, as we saw with Koa, we could write code that looks like synchronous code, but takes advantage of kind of nodes or UV or whatever it is on Windows is IO loop efficiency that we get with asynchronous code? And the answer is yes, we can. And we can do this with a construct called coroutines. So without going into what coroutines are yet, I mean, this should look very familiar to what was seen on the last slide, just outside of the context of Koa. What we can do here is we can write code that looks like this, right? And so the way it works is that we have this mystery function, coroutine, right? And we're actually going to dive into the implementation of coroutine later in the talk, which takes an instance of a generator function, right, which was explained in the last talk, and it returns a promise, right? And so the basic idea is that your generator function should yield promises, right? When those promises settled, right, if they're fulfilled, then the value from which it was fulfilled with will get assigned back to the left-hand assignment, right? If something goes wrong and it actually gets rejected, then the errors from those rejected promises are thrown within the generator. And just a little note here, while I used catch in this case, you could wrap this block in a try catch and handle the error that way if you were to be so inclined. And coroutines, most of the popular libraries, they return promises, so you can imagine they can interoperate with other async code that's written using the promises A+ spec. And really, you get the best of both worlds, right? You get the efficiency of your async I/O, and you get the readability of synchronous code. So maybe not as cool as Barack Obama with nunchucks, jumping out of an exploding plane with a shark coming out of a building, but still pretty awesome, right? So now that we've seen how awesome coroutines are, let's actually look at kind of the theory and the implementation behind it. So you may at some point have come across this concept of cooperative multitasking, right? If you remember back from your OS class or you do systems work, right? Basically, in traditional threading models, right? So like most of the time in the JVM, all the time if you're using like just basic POSIX threads, right? What you can do is you spin up a bunch of threads, right? And the executor, right, which is whatever the runtime that's managing those threads are. So I'm going to call this an executor. Sorry, the executor is responsible for actually multiplexing the running of those threads together. So if I have a computer and I'm running 5 threads on a 2-core computer, right? And let's assume it's just 2 cores, right? So no dual core or anything like that. Then at some point, the executor is going to have to be like, okay, run some of this code, now stop. Now run some other code, now stop. Now go back to the one that you were just running. Keep going, right? Cooperative threads are a little bit different. So cooperative threads are responsible for explicitly telling the executor when they should be suspended, right? And so you can imagine this works really great in I/O-bound applications, right? If I make an HTTP request, right, then really I'm just waiting around until I get a response back to do something interesting within that logical routine, right? So that's a great opportunity for me to say, hey, executor, like I'm not really doing anything right now, schedule something else to run. And most Node.js applications you write, given the nature of JavaScript and V8's runtime, are I/O bound, right? So you're probably, if you are, that would be really cool to hear about, but you're probably not doing a lot of like intense number crunching and things of that nature within your Node code. And, and so this works out really well if you're a Node developer, right? So generators give you your cooperation, right, through the yield keyword, right? When I yield in a generator, I suspend the context in which I'm running, which basically gives the runtime the opportunity to say, like, okay, schedule something else, right? And promises provide the routines, right? And so when you put those two together, you can basically have, once a promise is done running, you can yield a promise. When that's done running, it can resume the generator with the fulfilled value. And putting that generator and promise together gives you that cooperation and routine, hence your coroutines, right? So now this runs like if you go to the GitHub and you run the examples, then they will run as long as you transpile them. And this is the coroutine function that was used. It's about 25 source lines of code. Basically, all we do here is we check that it's a generator function. And if it is, we return this internal coroutine function. And so this internal coroutine function, it returns a promise. And basically, it's pretty simple the way it works, right? So the first thing it does is it calls it.next. And so it is an instance of a generator object which conforms to the ES 2015 iterator protocol with some sugar on top of it, such as throw. And when we call it.next here, so if there's an error in the synchronous code, right, we can catch it and then have a rejected promise handle that. If it's done, we simply resolve the promise with the value given. Otherwise, we essentially just wait for the promise to complete, and then we recursively, right, quote unquote, call this coroutine function again, passing it the same generator object in the value. And so as you can imagine, it'll continue calling this generator until such time it's done. at which point it will resolve with the final value. Catch is interesting. So what catch does is basically you want to be able to work with errors in that try-catch way. So what we do here is we throw the error inside of the generator using its throw method, right? And if it handles it, we basically just continue on with the coroutine. But if it doesn't handle it, then that error will propagate up to the context of the function that it was called in, and we'll never get to this return, and the promise will just be rejected. So, even though it looks like there's a lot of magic going on, it's actually pretty simple under the hood. It's 25 source lines of code. So you can start using this right now as long as you have some way to run ES 2015. You don't need a library or anything special like that. So, speaking of libraries, let's talk about some of the ones that already exist, because that's probably what you're going to want to use in your production code. So my favorite is Co. It's written by TJ, and he used to be Vision Media. This is a guy behind Express, the guy who's core contributor of Koa, and it's my personal favorite, and it supports thunks as well as promises. So, I know that's like the big, one of a hot debate within the Node community right now. Do we use callbacks? Do we use promises? So promises aren't your thing, then it does support yielding functions that just take a call, or yielding a function that just takes a callback as its argument, and that's actually exactly how yield next works in Koa. So Koa will, when next is a thunk, right, and basically when it's time for that callback to execute, if there's an error, it will throw in the generator, otherwise it will just resume it with whatever the value is given. Another cool thing about Koa is that it supports yielding arrays and objects, so works similar to async.parallel. If you give it an array or an object where it'll either wait for all of those promises cell and return it as an array of values, or it will assign each value to the key within that object, right? And it also, you can yield other generators, which it will just delegate to. And you can find that on GitHub at tj.co or tj/co. The second one is really cool. It's called task.js. It's written by Mozilla. It's been around, I think, for longer than Co has. It's similar to Co, but they actually implement a scheduler themselves within Task, which basically allows them to do a lot of really cool things like cancellation, which is something, as far as I know, you can't really do with promises right now without a lot of work, and even with that work, it's still going to be pretty janky, right? And what it does is it basically makes coroutines look a lot like traditional thread-based scheduling, which is great. There's a lot of research and a lot of theory and design patterns around traditional thread-based scheduling. And so you can find that at task.js.org. And then you might be thinking, well, this all sounds great, but I need ES6 or ES 2015. So as Eddie talked about, right, you can use Babel. I highly recommend Babel. When I was working at Refinery 29, we use it for some of our production applications. I've used it in things that are on production now. It works great. But if you don't want to use a transpiler, then you can, provided that you're using node v0.11 or greater, you could use Harmony generators flag or just _ Harmony. And if you're looking for not only a promise polyfill, but probably the best, in my opinion, implementation of promises outside of native promises, and in some cases they actually perform better, is Bluebird, which is Pekka Antonov's promise library. And if we get to some of the advanced examples, I'll show you some of the really cool stuff that you can do with Bluebird. And do we have time for advanced? Yeah? Okay, cool. So now what I want to do is, so what I've shown you looks good, but it really doesn't kind of, you might not be convinced that going through all this trouble of using coroutines is worth it. So what I want to do now is I want to show you some more advanced examples where this synchronous style code really shines. So the first one is, how many of you guys have ever worked with Python and used the retry module? Anybody? Okay. Cool, awesome. So this is basically retry, but for JavaScript. So a good example use case for this is like HTTP client. So if you've ever worked with Google's Java HTTP client, they have this notion of retry with exponential backoff. And that's basically like, I run the function, if something bad happens and I have some more attempts left, then I sleep for maybe 1 second with a randomized offset to prevent stampeding. And then then I run it again, and if it fails again, then I do the same thing, but for 2 seconds. And then again, but for 4 seconds, until the maximum number of attempts has been exhausted. And if I still haven't had a successful run, I throw an error. So you can imagine if you're writing something on the client side that needs to continuously attempt to connect to a back-end service, and you're building a mobile-intensive application where you could go on and offline, something like this is extremely useful, right? And next time you use Gmail and you go offline, check out their reconnecting in X seconds. This is very similar, I think, to the method they use in that. And this would be really tricky even if you were just using promises. You'd have to use some kind of recursive strategy, right, where you would have to kind of reconcile that with, actually waiting, right? So you'd have to do kind of like a lot of tomfoolery to get it to work the way you wanted it to work. With a coroutine, it looks exactly like it would look in any other language. You try for the number of attempts, you try and execute the function. If you get a value back and the value is a promise, you yield, so you wait for it, and then if that all works well, you break and you return the value. Otherwise, you continue to attempt it until you can't attempt anymore, and then you throw the error, right? And sleep is really trivial to implement. It's basically set timeout wrapped in a promise. So so that's the retry example. This next example I'm going to show you is what actually inspired me to do this talk, and that's database cursoring. So I was working on an application that dealt with extremely large result sets that all need to be streamed to a bunch of clients, right? And we're sitting around and we're like, okay, how are we going to do this without either like destroying Postgre, which is like what we were using, or destroying our application, right? And so we wanted to cursor, and we found that Postgre, this guy Brian C, who wrote the Postgres client for Node, also wrote this cursoring client, right? But actually in the repo, he basically just says, yeah, you're probably going to have to use some kind of like async mechanism to use this module, right? And so the idea is like you cursor until you run out of results, and then you just close down the cursor. And that, I think, would be extremely tricky to implement, even with promises, definitely tricky with callbacks. But with coroutines, you simply just use your canonical like input reading mechanism where you basically just say, while results is equal to yield cursor read async, do something with those results. And here, this example, it reads like a USDA food database and just prints all of that to command line. This is really where coroutines shine, because the difference between coroutines and other concurrency control mechanisms or async control flow mechanisms is that you can yield anywhere you could use a valid ECMA expression. So if you want to yield inside a while loop, that's 100% fine. Doing the same thing with promises or continuations would be a lot harder, right? And so I hope that those two advanced examples has given like kind of more of a motivation onto like why this pattern is so cool. And I just want to wrap it up here with some additional resources. If you want to learn more about generators and promises, which is kind of what make coroutines work under the hood, MDM reference is really awesome for generators, and HTML5 Rocks has an excellent tutorial on promises that was edited by Dominic Denicola, who was a very large contributor to that specification, especially in terms of A+. There's another presentation online by Forbes Lindsay, which is excellent, and it's basically very similar to mine. Promises and Generators, Control Flow, Utopia. There's a lot more really cool code examples there. And if you want to keep going with this, Axel Rauschmeier, who's got this blog Duality, explores how you can get coroutines without the need for promises at all. And basically, his trick is to use a deferred pattern. So if you're familiar with like the contract pattern or like the deferred pattern where you call success or failure, like he explores that in his talk. So thanks so much, and that's all I got. If you guys have any questions, I'd love to answer them. Questions? So the question was how performant it is to use both coroutines and promises. I can tell you only from my experience, because we tested this actually by using like V8 Civility and V0.12 to run perf, and we've looked at the flame graphs. There's very, very minimal overhead. So when you use promises, V8 has to retain some extra memory to deal with cleanup and resolution throughout the chain. So you're going to get a little bit more overhead, but it should be pretty minimal. I think if you're running into very large, if you're running into like large performance bottlenecks, then it's probably something else within your code. It could be some kind of network mechanism that's not getting cleaned up. If you're opening a lot of emitters and not handling closing them, that could happen. So I would also look for inside your promise chain. Sometimes exceptions could be swallowed. So if you open a resource and then throw it, and then an exception's being thrown, the resource might not be able to clean up properly because the promise state will still be opened, and that exception would have just gotten swallowed. All right, cool. I'll be around after this, so please come up and talk to me. Thanks so much, guys.
All right, that's it, everybody. Thanks for coming. One more round of applause for Travis, Jimmy, and Eddie. Remember, check out empirenode.org in the next couple of days. The early bird tickets are going to go on sale. If you guys want to be a presenter, be a speaker in front of the entire conference, get on there, click the big ribbon, and submit a proposal to do a talk. Other than that, thank you, Shutterstock, as always. Before you guys go, if you're around one of these black chairs, just fold it up and lean it up against the wall. We're going to bring the cart out, and we'll stack them all up. Thanks again for coming.